So the limitations of Fazan's rule. It is a qualitative law. One cannot calculate the percentage of covalent character. For example, we cannot calculate whether the bond is 60% covalent, 80% covalent, 95% covalent. We cannot find out the amount, the percentage of the covalent character. It can only be compared between two compounds. We can only find out which compound between the two would be more covalent in nature. Suppose there are two compounds, so which one of the two would be more covalent or less covalent? So what exactly happens here? Let's find out, like, how is this total thing of Fazan's rule being applied? What is it all about? So in case of, as I said, that Fazan's rule tells us about the covalent character present in an ionic bond. Okay, so let's say, obviously all cations are usually metals, and they are smaller in size, and the anions are usually non-metals, and they have bigger size. Reason being, obviously they are already loaded with a lot of electrons, whereas in case of metals they get rid of the electrons. So cations are usually smaller than the anions. So usually the anions have a spherical shape, but what happens is, after getting attracted, they slightly get distorted, which means their shape changes, they get deformed. I have also discussed about the electron cloud in atomic structure. Electron cloud is the density of the charge present. So initially, before getting attracted, the shape of the cation was spherical, but if you see, the electron cloud means the number of electrons are getting attracted by the positive charge of the cation. Can you see? So this is what happens. This was the usual shape, and then it slightly gets deformed, like towards this side, by being attracted. Like this should have been the actual size, like it was the actual shape, size, but due to the positive charge of the cation, what happens? It gets deformed, and this shape is formed because all the electrons get accumulated here. Okay, so this is called polarization, when there is a distortion in the electron cloud of the anion, because spherical size is the shape of the anion, but it gets attracted by the positive charge of the cation. So the size slightly, instead of being spherical, these electrons, due to which, gets bulged out towards this part. So this is called polarization. Okay, so basically, in fact, ionic compounds comprehend covalent character because of this polarization. So although it is an ionic compound, but polarization can be seen. And what is polarization? It is a part of sharing of electrons, because these electrons are shared by both the anion as well as the cation. Okay, so cation pulls the electron of the anion towards itself, due to which this shape changes and it slightly bulges out towards the cation. And this is why, because of the polarization power of the cation. So it's the polarization power of the cation. The positive charge of the cation is attracting the electron cloud of the anion, and due to which the shape has changed, it has deformed. It's no more spherical, it has become slightly bulged out this side. Okay, so therefore the anion gets polarized. So we can conclude that cation polarizes and anion gets